This video will walk through how we built the rowboat over the course of 6 months. Starting on the first day, our group got together and what we did was we listed all of our different skill sets on a whiteboard and then we started brainstorming initial ideas. After this initial brainstorming session, we stopped at the dining hall and then we also stopped at the Capstone lab just to see what materials there were we could use for our project. The Capstone lab pretty much became a second home for us as we were there for most of the semester. So after deciding on our project, we started on initial setup of our motors and our electronic speed controllers in order to handle our waterproof motors. So we watched a few tutorials and then were able to get our motors working. And then we started doing some testing with our ESC, our motor, and our battery, and then we accidentally shorted an ESC. This was a pretty big setback as we spent a couple weeks trying to figure out what the main cause was for our ESC and if we would be still able to use the battery that we'd purchased. We also met with our advisor Chuck on a weekly basis.
Yeah.
I just pushing up something, so this one. Yeah.
This one.
So this is the difference. Let's check the battery voltage.
After a few weeks of debugging and using our extra electronic speed controller, we realized that the fuse on the ESC had blown, and we theorized this as being a cause of torque overcurrent from the battery.
I don't know, let me try it again. We should try it with resistor. Yeah, that works.
We then did some more testing just to see how fast our motors could actually operate with the battery. And after doing some more testing, we realized that the ESCs and the motors we had initially been testing wouldn't work for our project, so we had to pivot.
With the 0.3,
Afterwards, we decided to use some Apis Queen's thrusters, and we did some testing with an Arduino microcontroller and our power supply just to see what speeds we were getting for our motors. And then this test here that you see is the first time we actually hooked it up to our battery.
Wait, how many amps is it gonna pull? Like assuming like running at 16 point something.
Unfortunately, after connecting it to our battery, the motor wouldn't power on and we heard it click, so we had another issue to solve. So our workaround for this issue was we used our power supply to provide power for our motors, and then we send PWM signals to our thrusters.
Nice. Alright.
So this was our way of controlling the speed at which the motor was spinning. And then once we got this working, we tried incorporating it with our PS4 controller just to establish the manual control. And this here was our first success, which was a big milestone for us. Next, we did our first full dry run of our entire system. We also added a circuit breaker just to help with protecting any overcurrent issues that we were previously having when we were testing.
Okay, and now it's going to be both at 50%. Both 50%. Sure.
Yay!
So we're testing our thrusters.
Tell the audience.
First test underwater. So.
But is it gonna work?
It should work. Okay. It's probably gonna splash everywhere.
Yeah, I know it's gonna splash.
We started by testing only one motor underwater and then slowly ramping up the speed of the motors through Arduino. And this, like I said, this was our first time testing these thrusters underwater, so we really wanted to see how much propulsion we were getting with our
Nothing
system.
is
We're at
smoking.
25.
Yeah, it's like a nice
25
hot
out of
dog.
100.
I'm glad it's pushing it this way. 30%? 35? Yeah, you can do 35.
There wasn't much difference. Ooh, okay.
5% increments. 55? Yeah, 45. Alright, 55. 60. 65.
It's like
70. 80. 200. Alright, you can turn it off.
After testing our first motor, we tried testing both motors at once, and then we also tested
even at a 4
if we could turn the motors in different orientations, as that would be the way we'd control our boat.
Okay, good. Now, 25, -25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25. 25.
After we verified that our system worked, we then started preparing our waterproof box for our first day of pool testing. All our electronics were housed in an IP68 waterproof box, and then the motors would be wired through with cable glands. That's the reason why Oliver is drilling. Fast forward to our first day of pool testing, we tested on campus at the cabin pool.
Oh, it's microphone. Hello. Hello, what song are you listening to right now?
Michael, what's going on right now?
Right now, we're fastening everything into a box. We're putting the camera in, and then we're about to test it.
Ooh.
3, 2, 1.
This first test really was just to see the buoyancy of our structure and also start testing the person tracking algorithm
Backwards.
and seeing if it was effective in the water.
Backwards. That's pretty quick. This is max speed.
Here are just some clips from the first day of testing.
It can outswim Oliver.
So overall, we thought the first day of pool testing went pretty well. We saw how buoyant the Lifeguard boat was, and that helped us with making some design changes and iterations before our second day of testing.
So what's going on?
It's detecting me, and when I move, it's trying to move in my direction. So now I'm moving to the right, so it's trying to move to the right, and now I'm moving to the left. So it's trying to move to the left. Just a little bit sensitive. And now I can go really close to it, and it stops.
Allegedly.
This close. Okay, good to know.
We also worked more on the camera tracking algorithm just to have it be more effective with picking up on a drowning individual.
That's the laptop, the suitcase.
Make it more realistic.
I can. Okay. Oh my God, he's drowning. That's the biggest drown I've ever seen.
Warning, arming checks disabled. Armed. Flight mode change failed.
No.
Disarmed.
Disarmed.
Oh my God.
Arming checks disabled. Armed.
Guys, it's drowning.
No, no.
I was gonna get it to drown with him at some point.
I survived. Thanks to the robot.
So before the second day of testing, two key changes we made were we added more PVC to our structure at the bottom base, and then we also added a third thruster to make our system go even faster, just to help with increased emergency response times. Day 2 testing went pretty well. We tested more in the deep end this time, and then got this clip that was included in our final demo video of the auto tracking feature working. For day 3 of pool testing, we focused on getting videos for our final demo video. One of the big product requirements we had for this project was that our boat needed to be as fast as the average lifeguard or an average swimmer. So that's the reason why we tried to get videos of us racing against the robot. Overall, the lifeguard boat moved as fast as an average human, and yeah, this was a lot of fun to film. We also filmed our rescue sequence fully on day 3, and you can find the full rescue sequence in our final demo video that is linked. And with our 4th and final pool session, I got in the pool just to help with the camera tracking algorithm, and we did some more testing just to make sure that everything was good to go before our beach film day. So then we took our boat to the beach and then filmed different angles of it going in manual mode. The big thing that we wanted to get here was to show its durability and its real-life application of how it would be able to move in harsh aquatic conditions, and as this was one of the big goals of the project. It was a great success.
Like, I think another good thing is, like, you know, if I went in there to save somebody right now, I'd freeze to death.
Yeah. Oh,
Whereas this guy is...
So this video was just sort of to give you a bit of a glimpse of the behind the scenes of our Capstone project. If you want to see more videos about my Capstone, you can click here to see the Capstone presentation day, and you can click here to see the demo video. Shoutouts to all of my team for the great Capstone experience, and it was a lot of fun working on this project.